Welcome back to another chemistry video on the periodic table. I know the table very well. It's something I'm very well known for. The trends that's what we're going to look at today. Let me tell you something about trends. They're all very positive. We have very positive trends right now. They're going up. You're going to find that the periodic table, not so good with trends. Actually has some of the trends going down, which we do not want in this country. I'm sorry, I had to throw a little Donald Trump in there somewhere. Welcome back, folks. Today we're going to focus on periodic trends in this YouTube video. As we mentioned before in the periodic table, I can't get that out of my head now. As we mentioned before on the periodic table, there's lots of really unique trends that we can see based on the design of the periodic table. We're going to take a look at some of those in depth today and what those mean for chemical bonding and things like that. So our learning targets today, hopefully we will be able to explain a variety of properties and the trends that can be determined from these properties on the periodic table. And also, something we maybe should have discussed a little bit earlier is understand the importance of the Octet Rule and how atoms behave because of it. Just a few of our vocab terms for today. We'll talk a little bit about atomic radius, ionization, electron affinity, and anion, electronegativity, ion, ionization energy, cations, valence electrons, and of course, the octet rule, which hopefully you know oct is the root for 8. So, as we look at the periodic table, there are several major properties that show trends across the periodic table. And these are things like the atomic radius, the ionization energy, electron affinity, and electronegativity. We'll discuss what each of those are as we move forward in this video. So first and foremost, the atomic radius is half the distance between the nuclei of two similar atoms that are bonded together. So as you know in geometry, the radius is equal to half the diameter of a circle. And the atomic radius is a very similar concept. This helps us to define the size of an atom, and this is a trend that we're able to see on the periodic table. So if we take a look, the radius decreases as it goes across a period. So if we go from left to right on the periodic table, the atomic radius actually decreases. And this kind of has to do with the concept known as nuclear shielding. But as there are more electrons in an orbital, it means that that orbital has more of a negative charge. More of a negative charge means those electrons are going to be pulled in closer to the positively charged nucleus. Thus, the radius of the atom is going to get smaller. If you look at lithium, lithium only has one electron in its outermost shell. That's a fairly weak negative charge, so it's going to exist in an orbital that is larger around the nucleus. As we add more electrons, that orbital has more of a negative charge, thus being attracted more to the positively charged nucleus. Furthermore, the atomic radius increases as we go down a group. We talked a little bit about this before as well, is that higher energy levels are going to be further away from the nucleus. The 1s orbital very close to the inside. As we go to the 2s, it has a higher energy level, therefore it is further away from the nucleus, and so on as we go down the periodic table. So the way to keep in mind with this is that atomic radius is highest down and to the left, and it is the smallest up and to the right. So again, highest down and to the left. Down and to the left, down and to the left. If you've ever seen JFK, you'll get that joke, but most of you guys were probably born in the 2000s, so probably not. Ionization, let's talk a little bit about that. Ions have either a positive or negative charge due to either gaining or losing an electron. If we gain an electron, we have a negative charge, and if we lose an electron, we have a positive charge. Now, the process of doing this is called ionization. Okay, and the amount of energy to remove one electron is called ionization energy. So you can think about where this would be highest and lowest based on what either wants to gain an electron or wants to lose an electron. So keep in mind that nearly all atoms follow the Octet Rule, which says that they are most stable when they have 8 valence electrons. So atoms form ions by either gaining or losing electrons in order to become stable. Now to do this, they chemically bond with other atoms that either want to gain or lose electrons. And as a result of this, they become stable. That's the whole reason why atoms chemically bond, is in order to get to a stable level of valence electrons.
So I brought this slide one more time just to give you a better idea of what valence electrons are, how we know where they're located and whatnot. So it's actually pretty straightforward trend along the periodic table. We tend to kind of ignore these because these have variable valence electrons in the D block. But here, because there's just one s electron, this group has one valence electron. This has two s electrons, so this would be 2. And moving on down the line, we've got 3, 4, 5, 6, 7, and 8. Now, if you remember, they want to have 8 valence electrons. So these over here, like for example, if we look at the group number 1 here, if we have 1 valence electron, we can either gain 8 or lose 1. Well, it's a lot easier to lose an electron than it is to gain 7. So these are likely to lose that electron. Same here and same here. With 7, it's more likely that they're going to want to gain 1. It's more energy efficient to gain 1 than it is to lose 7. So we're going to gain, gain, gain. And here, this can either lose or gain electrons. So just some things to kind of think about as we go through and think about how we determine what's likely to gain an electron, what's likely to lose one. We need to think about the octet rule and how the valence electrons apply in that particular situation. So looking at some trends related to ionization, the ionization energy increases as we go across the period. It becomes much easier to remove an electron from the nucleus. What that means is that the further left we are on the periodic table, the lower the amount of ionization energy. It's much easier to move an electron that's further from the nucleus. And if you remember from our atomic radius, all of the electrons, like the 1s electrons, 2s electrons, are really, really far away from the nucleus. So it's very easy to remove those. If you take a look at the chart, the individual atoms that have the highest ionization energy are your noble gases. The reason that is the case is because it requires a lot of energy to remove an electron from a noble gas. That's because they already have 8 valence electrons in their outermost shell. They do not want to get rid of an electron. The stuff on the far left-hand side is very desperate to get rid of that electron and will remove it very easily. Additionally, ionization energy decreases as we move down a group. Electrons, again, are easy to remove if they're further from the nucleus. So if you remember, the atomic radius gets bigger as we go down a group, which means that it's easier to remove an electron. So for example, if we look at the valleys of all the graphs where we have lithium, sodium, potassium, rubidium, cesium, the ionization energy of cesium is very low. That means that it's very easy to remove that electron. Whereas if we get to lithium, it's still easy to remove, but it's not as easy to remove as cesium is because the atomic radius of cesium is larger. So keep in mind that ionization energy is highest up and to the right. It's the hardest to remove an electron from a helium atom. It's the exact opposite of the atomic radius. Atomic radius is highest down and to the left. Ionization energy is highest up and to the right. Electron affinity is the energy change when an electron is acquired. Some elements easily gain electrons and some do not. So think about it. Those with 7 valence electrons are more likely to gain an electron than elements with just 1. Those with just 1 want to lose it. So the electron affinities are going to be highest to the right because there are 7 valence electrons there. Now there's no electron affinities for your noble gases, again, because they have 8 valence electrons. They do not want to get rid of that electron in its outermost shell. So electron affinity tends to increase as we go to the right. Halogens, which have 7 valence electrons, want to gain an electron, so they're more likely to be so the energy is more likely to be favorable for them to gain one. Alkali metals don't want to gain, they want to lose, so the energy is not very favorable for them to gain an electron. This also tends to increase as you go up a group. So again, electron affinity, similar to ionization energy, is highest up and to the right. The only difference here is that with electron affinity, the noble gases do not want an electron at all. They have 8 in their outermost shell and therefore do not want to gain or lose an electron. Now, when we talk about ions, there's 2 real important terms that we need to make sure that we know. There's positive ions, which are called cations, and they lose an electron, and anions are negative ones, meaning that they gain an electron. All in the name of getting 8 valence electrons. That's very, very important. The last bit that we need to talk about is what's called electronegativity, and it's the ability of an atom to attract electrons from another atom. So just think about it. Which side of the periodic table would you think is more likely to have atoms that would want to attract electrons? Well, if you guessed the left side, you would be completely wrong, because if you remember, they want to lose electrons, not gain them. So, electronegativity tends to increase as you go from left to right on the periodic table. Again, those with 7 valence electrons really want to attract an electron to get that octet. Electronegativity, similar to ionization energy and an electron affinity, is highest up and to the right. So again, another relatively long video, but hopefully you understand the concepts of most of these periodic trends. Atomic radius is highest down and to the left. Ionization energy is highest up and to the right. Electron affinity is highest up and to the right, except for noble gases. And electronegativity is highest up and to the right, again, except for noble gases. Thanks for watching. I really appreciate your time, and we will see you in just a little bit. Have a great day, guys. Bye-bye.